Okay, good afternoon, everyone. Dr. Jensen here. So today we're going to talk about electrochemistry. So this particular video will be covering the lab simulator dealing with electrochemical reactions. So if you are following along in our course, you most likely have this handout that deals with electrochemistry for voltaic cells. And this is the online version. So it kind of gives you some background on the mechanics of how a voltaic cell works, dealing with, we have anodes and we have the cathode. There's various solutions that we're operating here, and then a salt bridge, which allows for the transfer of ions and electrons around the system. Okay. It discusses things like the shorthand notation for a voltaic cell, which is something you'll have to be able to do. And really the bulk of the work that you're going to do here are calculating E naught for the cell. Okay, so the cell potential for a variety of cells. And this is done for pretty much any chemistry lab. There's whether you are doing this in person or you're doing it via simulator, the mechanics of this basically work out very much the same way, right? You're given generally two reduction reactions. Again, half reactions are generally how we would start things. So we measure everything apples to apples. And so you're going to compare the reduction potentials of these two half reactions and determine which one should be at which anode, right? So, or which electrode. So the one that's more positive is going to be your cathode. Okay, the one that is more negative is going to be the anode. Okay, so the cathode, so if we don't remember this, an easy way to remember this is the anode, A, starts with a vowel, and so does oxidation. So that is the oxidation one, and the cathode is consonant, so reduction is there. And so the reduction is the gain of electrons. And so in this case, copper, the copper 2 plus is more likely to go as it's written. So it is stronger in the reduction potential. And so that means the other one would have to flip around, right? Which then puts the zinc metal as your anode, okay, where the oxidation is occurring, where the loss of electrons is occurring, okay? Because when you look at the cell, the electrons that generate the electricity are generated from the anode. Okay, the anode loses the electrons, and that's what causes the cell to operate. Right, is the loss of electrodes from the anions, the gain of electron from the cathode. And so this is why over time we see the anode would essentially degrade away, because as the zinc metal loses electrons, it becomes zinc 2 plus. And then during that process, little pieces of it break off and dissolve away into the solution until at some point you have no more zinc metal, because all of the zinc metal atoms have given off their electron, and so there's nothing left to generate electrons, and therefore your battery would eventually stop, right? So you're essentially going to be doing combinations of reduction potential reactions and determining what is the cell voltage. Okay, there are half reaction data tables, so you could look these up in your book as well. So these are common data tables that are found within our books. Okay, and essentially this is the main data table that you're operating from. Okay, so they do the first one for you, the zinc and copper. Right, so we have the zinc copper half reactions. So again, these would be copied essentially straight from your book, right? So these are in the table. So like if you go up here to, here's the lead one, okay? Here's lead, going to lead plus 2 electrons making lead, okay? So that would go essentially right here, okay? Here's your lead reaction. So that same reaction is gonna be copied right there. And what is the E cell potential? Okay, well, lead is right here, -126. Okay, that's going to go in this column where it wants to know the standard cell potential. Okay, you're going to determine whether or not lead is the anode or the cathode. Okay, based on this combination, we're going to look at the copper and the lead. Okay, the copper and the lead. Okay, copper is again the more positive one, so the copper is again going to be the cathode, and the lead is going to end up being the anode, right? And then you have the potentials between the two, right? So as you add the cell potentials together, okay, whether you are turning one of them around, making it positive, right? Because the half cell reaction for the oxidation potential would flip around. That would change the sign on its electrode potential, and then you would add the two together. And so you have tables of the E naughts, and so then we're going to add the potentials together in order to get the E cell calculated. And then you can compare this to what you get for experimentally, because you can set this up in the simulator and put one of them as the anode, put one of them as the cathode, and it gives you a little reading on the spectrometer, okay, or the voltage meter, okay. And so this is the bulk of what you're essentially doing, is just mixing these various solutions together and measuring what is the E cell potential. Okay, most of this you can do without actually having the simulator. You don't need hardly any of this for the simulator. You can do all of this by hand without the simulator. These are all normal reduction half reactions. You can mix these together and determine cathode anodes and determine E cell values without putting anything in the simulator. Okay, so the simulator is just looking at what did you get actually, or it gives you a relatively random / realistic approach, to it mimics a real approach to what you might get in the cell. But you can see here that the E cell value was 1.1, and the experimental value was also 1.1, right? And so if it obviously came out negative, that would mean you had the two swapped, right? So that's essentially the instructions here. Is we're going to set up the voltaic cell from table 2. Okay, you have to use the solutions appropriate for each one, and then click measure the cell potential, and then record the value that's there. Again, this is very straightforward. There is very little deviation to this as far as the procedure goes. You are mixing these metals together and measuring what is the output. Okay. You have a random cell. So there's a way to click on and have it give you a random cell. And so you essentially are going to determine what are the dynamics of the random cell. And you're just writing down what is the information that it is generated for you. Okay, because it just gives you a random example, but a lot of the random examples are very similar to these solutions up here. Okay, and then part D is really again another kind of random example, and then here you're just going to draw or label your solution. Okay, which again you would essentially derive from the simulator. Okay, so let's take a look at what the simulator looks like. Okay, again, the link is on the handout. Okay, and here we have the simulator set up. Okay, so the website is, as I said, it is relatively straightforward in how this gets conducted. There is very little real way to mess this up. Okay, if you're just following the instructions. Okay, so it asks for what is the electrode on the left that you want to have. Okay, so the left, the right, right, and so we have copper and zinc are our first two. Okay, so say we'll pick copper. Okay, and it even puts a little copper-looking electrode in there. The electrode on the right, well, we want to put zinc in there. Okay, even puts a little silver electrode on that side. Okay, the solution that goes with it should match the electrode. So the copper nitrate is the solution that you want to put it in. The zinc nitrate is the solution you want to put it in. Okay. And then when we measure it, now you see when I set it up, okay, there's the voltage potential, but what did I get? I got negative 1.1. Now my calculated value was supposed to be 1.1. That's because I put them in the wrong order, okay? And so like I said, it's very easy to understand if you've messed up, okay? The potentials shouldn't be negative if we set it up right? So you can clear. Okay, we can clear the solution. Okay, you can also change the concentrations of the solutions. All right, so here I want to put my zinc on this side with the zinc nitrate, and I want to pick my copper and my copper nitrate, and then measure the cell potential. And then this is the data you're collecting. Okay, so there really isn't much more to it than this. Okay, so play with the various values, okay, and you want to record as best you can. Now you should have some notion of what the cell value is going to be before you actually go and put things in the solution, okay? So that way you can compare your actual value to the theoretical value, okay? It has all the various electrodes in here, okay? Silver, nickel, magnesium, lead, iron, copper, okay? So all of those solutions that the handout is calling for are here. And likewise, their relative solution is with it as well, okay? So if you change the problem level, so this is where you go to change the problem level. So if it gives you a random solution, okay, it already generates the solution for you, okay? And so you're essentially following the instructions to measuring the random solution that has been generated for you. Okay. So hopefully this one is relatively straightforward. There really should not be much in the way of things that jump out at us here for this problem. And so go ahead and give it a try. And like I said, if you mess it up, you can always just reset the simulator and give it another shot. Okay, that's it for now. And this is the Electrochemistry Simulator for Chemistry 112.